All right, I think we're live. Yeah, looks like we're live. We're ready to go. So look, if you're here to learn about large language models in the enterprise, you're probably in the right place. If you're supposed to be working, turn the volume down so your managers don't hear you listening to this instead. Now, I'm going to be joined today by a lot of panelists that we're going to be talking about maybe the depths of large language models in general, but also like how do you adopt this stuff in the average enterprise? So if you don't know what a large language model is, don't worry. Our panel of experts will explain that to you. And I'll be representing you in terms of asking more curious questions about how does this stuff work in the real world? You also have the ability to ask your own questions in the comment section. So if you got a question, drop it in that comment area. I'll pay attention to those and raise them to the audience. And also, I think you can do some call-ins. I don't know how that works, but if you remember your registration email, you should be able to request the ability to come on stage, and we'll let you ask your question in person. Keep in mind, this is being recorded. So if you don't want to be seen in the recording, do not raise your hand to come on stage. You will be in the recording. All right, so to get us started, we're going to have each of the panelists introduce ourselves. So I'm just going to go from top to bottom based on what I see on my screen. So Harrison, if you could unmute yourself, introduce yourself, and tell people a little bit about your background.
Absolutely. And I think I should be unmuted already. I was not a good panelist and I did not mute myself to start. So I'm already not following instructions. But my name's Harrison. Great to meet everyone. I am CEO and co-founder of LangChain. LangChain is, LangChain is now a company, but it started off as an open source framework for building LLM applications. Started last October, end of October, early November of last year. Started as a company in January. We've got Python, TypeScript package, and before that, my background's in ML and MLOps. Worked at a few companies doing that. So that's kind of the perspective that I'll bring.
I got a quick question on that. So you're a developer, you got your app. You probably got some app where you're selling ice cream over iPhone, who knows? And you're like, I need to use LangChain. What would they be using it for? And what does that developer experience look like in terms of layering this into an existing application?
Yeah, absolutely. So the core of it is basically connecting LLMs to your application and kind of like acting as a middleware between the underlying LLM and then your application. And so why is that necessary? It's necessary in the cases where you're trying to build more interesting applications that aren't just kind of like a simple call to a language model. So if you're just calling like the API, you don't need LangChain. Where LangChain kind of excels is in helping you build context-aware kind of like reasoning applications. And what I mean by that is like LLMs are great, but they don't know everything. And so when you need to bring external context to the LLM, whether it be data, whether it be kind of like instructions on how it should behave in your company's context, whether it be kind of like specifications of APIs that it can call, and then have it reason about those things. And then there's also the concept of chains, hence the name, which is basically sequence of these things. So as a simple example, you can kind of like reason about through an API spec and some context, what parameters you should send to an API. You can then get back the response and then decide what to do next. And sometimes you can return that to the user. Sometimes you can realize that the response, you got like a 404 or something, and so the request that you sent was bad, and maybe you should try again with some slightly different parameters. And that's where like using the language model as this reasoning engine to decide, like there's so much human ambiguity in how we speak, right? And so having the language model take that and reason about specific actions of what to do, those types of actions are where LangChain helps excel.
I promise I'm going to move on. Coming from the symbolic programming world, if then else. And some people think about that as like decision trees and decision making. And it sounds like all of this is like one level up from that, this idea of reasoning. Some would say maybe you're using the word reasoning a little too early in the stage of LLMs. Sure. But is this kind of the way developers should be thinking about a smarter way of making decisions?
Yeah, the way, and so there's also like this distinction in LangChain between like chains and agents. And agents are a bit of an overloaded term. And so specifically what I mean by agents is when you're using the language model to determine what sequence of steps to take and in what order. And then chains are when those are kind of like hard-coded in code. So like if and then stuff like that. And so I think like there's pros and cons to both, right? Chain's much more controlled. They don't go off the rails. You can kind of like control them much more easily. The benefit of where agents come into play is that they can handle a really long tail of events. And so if you start having like really complicated, like if this, then this, if this, then this, if this other thing, the idea of an agent is basically, okay, don't write all that complicated code, have a language model kind of like decide what to do and kind of simplify the logic there. And so again, pros and cons to both. And I'm sure as we talk about how enterprises are adopting this, we'll talk about the pros and cons of some of these more out there things compared with the stuff that you can reliably do now. But yeah, there's that idea of using the language model to take away this like complicated branching logic that starts to develop.
Dope. Thank you for that. Next up on my list, I have Steph. Steph, if you could unmute yourself, introduce yourself.
Hey, I'm Steph. I live in Berkeley, California, and I've got a background in LLMs kind of going back to the Facebook days. I was working in translation and language understanding for many years at Facebook, and sort of developed and productionized some of the first large language models, models like Roberta and XLM in like 2018. And then later I've applied LLMs at Stripe in kind of the merchant fraud space. So yeah, that's about my background.
The one question I have for you is, you talked about like language translation. Mm-hmm. And so when I think about that, computers are getting better at this understanding of language thing. But if you had to compare it to, I meet some people that know like 7 languages, like fluently. Mm-hmm. Where would you compare in 2023 where the machines are and people that are like linguistics by training? What would you say they kind of rank in terms of their ability to comprehend and understand language?
In translation specifically, or like language understanding? I think
language understanding, right? They say children start understanding language before they can talk, right? So like, where do we compare?
Yeah, I think there's a great article in the New York Times on this like 5 years ago about just how far language understanding is from like a real sort of linguistic translation. Like, it's really shocking how powerful these modern language models are from the perspective of a technologist, and like where language understanding was 5 years ago. But it's still like, it still feels almost infinitely far away from like a real person in a lot of senses. Like understanding like basic context about like who the speaker is something that language models like really, like you can kind of like supply that with prompting to some degree, and like you can find some like really compelling examples if you like cherry pick them. But in terms of like an individual's ability to like reason about context, I think we're just like we're like still as far away as we were almost 5 years ago.
I appreciate that additional context, especially as someone that works at an enterprise trying to figure out, are we Star Trek? Or are we just kind of making progress over like things like Siri, right? So I think it just really helps ground the conversation. So I really appreciate that additional context. Next on my list is Naylan. If you could unmute yourself, introduce yourself, and welcome. Uh-oh, you might have dropped.
I lost Naylan for a little bit.
Yeah, see, like we can't even stay connected to the internet. All right, with that, we're going to keep moving. Let's go with Keithan. If you could, unmute yourself, introduce yourself.
Hello, thank you for having me on this panel. My name is Keithan, and I created Flight, and I'm the open source chair for Flight. But I'm also the CEO and co-founder at Union. At Union, we are building AI infrastructure. It's a company where we think the core of it is an orchestrator, which is powered by Flight, but an AI infrastructure encompasses larger area than just orchestration.
Keithan, I think you're the first person, I became an advisor, I think last year. You're like the first person who introduced me to the term ML ops.
Yes.
First of all, what the hell is ML ops? And why is it important, especially for the enterprise that's trying to get into this for the first time?
Yeah, it's interesting because I actually, and honestly, on this panel, I do not have complete background in LLMs. What I have a background is getting machine learning models into production. And that's where all the challenges come to play. What happens is you start with an idea, and oftentimes I've seen machine learning scientists come up with cool ideas, but very few times I've seen many of them make to production. Right? What ends up happening is they get lost in the sea of, oh, here's an idea, and how do I finally put it in production? And the reason why that happens is infrastructure, management of the pipelines themselves, management of in production. Right, you are now reliant on your model or a service to be providing real values, quality answers, right? And that, if you take the pure software terminology, we have been pioneering how to deliver software consistently, reliably. And I would still say it's not like 100% done, right? Now here in the world of ML, the world of ML is completely different. Like an idea that starts off today, works well in practice today, may absolutely not work in 6 months. And that's because assumptions have changed underneath. And now what people have been trying to do for some time is take the software engineering principles and apply them to ML. But the fundamental problem itself is different. ML is constantly moving. It's this variable thing. And now you're trying to put it into this strict forced way of thinking about the way we think about software. And I'll give you an example, right? Let's think about a database. 3 years ago, if there existed a database today, it's probably better. They started off with an idea that I will build indexes, I'll build LSM trees, blah, blah, blah. And they keep on improving. They keep on improving performance characteristics and so on. With machine learning models, that's not how you do it. Machine learning models, you start with an assumption. For example, it's not COVID 2019. You want to deliver, let's say you want to do some coupons and you want to get a lot of people onto your platform, your DoorDash or your Lyft or your Uber. So you have different assumptions and you go based on those. And pandemic hits, all your assumptions have changed. There's nobody on the streets. Uber and Lyft cannot get people into the cars. How do they now use machine learning to incentivize those people? The incentivizing process has to change. So in this kind of a changing environment, you need a different process, a different set of tooling that takes you into production reliably, let you do this consistently, repeatedly, and reproducibly, right? Which things are, so this is what is in general a term the MLOps was coined for. Now, because it was not very well crisply defined, everybody is free to take their own spin on MLOps. But the idea is to take whatever you've tried in this pure research environment into production so that customers can get value from it. And even in the LLM world, some of it for a while remained in that research environment. And we actually saw some really good, interesting ideas put into production. And that's where caught everybody's, we almost caught everybody's imagination saying that, oh, wow, ChatGPT can do X, Y, Z. And that's where, that's the difference. Like you take something from idea to production. That's, in my opinion, that entire field is called MLOps.
Yeah, I think it helps people really think about traditional software. You almost has a 6 foot of rules. If this, then do this. If you put this in your cart, it costs $5. You buy it. That's it. Either we have it in stock or we don't. Very easy to program in that way. But I think when we think about ML in general, we're moving closer to people.
Yes.
And when you're dealing with people, you got to be able to read the room. And so one model may no longer work in a different context, and you're just going to make the wrong decision. The right decision, driving a car during the daytime, could be very much the wrong decision in the evening, or after major construction work has been performed. Your model may now be obsolete because we've never made roads that way before. And so I think this need to be dynamic and the ability to read the room introduces a whole new challenge in terms of maintaining software that most people may not be thinking about. All right. I think our last panelist that we have online, Amish, if you could unmute yourself, introduce yourself, and welcome to the stage.
Yeah, thanks for having me here. Glad to be with you all. I'm currently at LinkedIn, executive director for our AI platform efforts, which include our distributed training platform, fine-tuning platform, machine learning pipelines, AI metadata, and other related efforts. So essentially, a lot of the core products you need to build for realizing MLOps and now LLM ops, right? So that's another term. And before that, I was part of IBM Watson, distinguished engineer there. leading a lot of efforts around creating the Watson platform, around distributed training pipelines, etc., working heavily also with the open source communities. I was one of the co-creators of Kserve, which is part of the Kubeflow serving platform, one of the co-creators of Kubeflow pipelines on Tekton. All these projects are now part of the different arms of Linux Foundation. So work very heavily with Linux Foundations in terms of also launching a lot of trusted AI projects around AI fairness, AI explainability, etc.
Watson was probably the moment that people are experiencing today with like Chat GPT. I think Watson for me was that moment, especially the whole Jeopardy thing. Like beating someone in chess, okay. But watching it play Jeopardy is the first time I felt like, okay, we are now entering the Star Trek era. And the reason why I thought that you can call it a presentation, a demo, but it was real, was so interesting is because the machine was next to the humans in a context we understand, a game show. And I think for a lot of people, it was seeing like the tech actually meet what people would consider normal people and outclassing the best consistently. And so to me, that was that aha moment. And so I'm definitely like a big fan of Watson, but I also think Watson, people thought it was going to become, I don't know, the Serenity. Like people thought this was the end game. And then it went away. It felt like that was it. Like we had reached this peak. I guess I have two questions. Number one, kind of what happened to Watson? And then how do we be careful right now not to overhype LLMs as like this thing that was going to bring AGI to the world?
Very good question, Kelsey. I think definitely, it was back in 2011, right, when Jeopardy came in, and that was quite a bit of aha moments for a lot of folks, right? AI can actually, go and beat the Jeopardy players, and I think, it was a system which was heavily customized and trained on that data set, right? And over the period of time, right, definitely that was something which was done in terms of establishing a moment, showing the capability, but beyond that, the commercialization aspect. Okay, how can we take this idea that AI can actually do natural language processing and apply it in real world? And that's where Watson evolution has gone in the last few years. So a lot of the things which we are seeing now, for example, ChatGPT coming and democratizing this whole NLP space overall. But if you see in general, like back it was around 7 to 8 years ago when Watson launched a lot of these services around natural language processing, speech to text, text to speech, sentiment analysis. They're running still in public cloud, definitely catering to enterprises and being used as chatbots across a lot of the enterprises. So a lot of the enterprises we interact with, and I don't want to take names, right? But they're essentially, when you are actually going and using their chatbots, you'll find Watson behind a lot of them. So it's still there, thriving. A lot of the ready-made services are being sold, and also the platform, right, which powered that, right, in terms of distributed training model, inferencing, machine learning pipelines. That's another set of product offerings, right, compared to something like which you see in Google's Vertex AI portfolio or SageMaker, right? So it's a similar portfolio of Watson X products, right, which has been launched both on the private cloud as well as the public cloud, and doing good, right? I mean, if you see the overall Gartner and other ratings, it's almost always there in the leaders quadrant in terms of that. So I think, yes, definitely the Jeopardy moment had a lot of promise, but I think the thing which probably was missed was that it was curated, customized on that one particular data set, and that's why we saw the results we saw. Fast forward now, what has happened with ChatGPT is, okay, now it's not that one particular data set, right? It's a data set, right, which is so huge. These foundation models are being trained on, the amount of data sets, which is mostly accessible to these web scale companies, etc., right? And that's why they are essentially, more generalized, able to answer those things now, instead of, being constrained by enterprise settings and being able to answer and reason for a particular enterprise. They are able to be the general purpose models they are there, right? But it's the democratization of that idea, right, which has been floating out for the last decade. Yeah.
That's perfect. So look, we have a lot of topics to cover. When I spent some time in the average enterprise myself, I've worked at financial institutions, not the fancy ones with the fancy technology, not those. The ones where you're going to really spend months to release anything, right? Where everyone is afraid of regulation. No one wants to make a decision about anything. So when I think about enterprise, that's what I'm thinking about. I'm not thinking about people that are just looking for that last 10% to outpass their competitors. Not that. I'm thinking about those companies that really need the most help. They're really focused on a core business and they hope that technology will somehow assist them. And the same enterprise, when I think about the people who work there, right? You know, that person's been there for 10 years plus. They have a pretty good mental model of the business, right? Like they walk around in the very natural sense of a model. They know what's being sold. They know how it works. They know what breaks. They know how the system performs. And they can just look at a graph and tell you something is out of stock. Hey, what is out of stock in Home Depot? That's what that graph means. Like, how? It's like, yeah, I've seen enough. I've been around enough. And I think a lot of enterprises are trying to take that type of thing, that idea of a model, and put it in the machine. So the machines can be making these type of decisions because we have no idea the type of input that goes into a seasoned veteran with 10 years of experience building up a real world mental model. And so I think a lot of enterprises are there. They have people that are walking around in that company that have pretty strong models of how things should go. And maybe they can make decisions if they're pulled in and given enough context, but they want to scale that, right? They want to scale that to bring this capability to their end users, everyone in the organization. So when I think about LLMs, this ability to take this concept and layer it on top of their data, where do people start? So anyone want to raise their hand, unmute yourself and go from there. I think given that foundation, they're already doing data analytics. They know how to run SQL queries. They got a lot of Excel spreadsheets open right now. They're probably watching this with 50 spreadsheet tabs open right now. What is their step into this world?
Well, I can take a stab at this. I mean, first of all, I think like part of the beauty of large language models is that they're so general. There's so many different applications. So I think choosing kind of like one entry point is a bit tough. That being said, like I think there are a few kind of like natural places to start. One of the biggest unlocks here is that you can use unstructured data now in some way. Like by far the biggest application we're seeing is some sort of like chat with your data, like Chat GPT, but it knows your data. And I think like the easiest version of that is if you have documents, there's a pretty standard kind of like formula for kind of like inserting them into context and answering questions about it. And it's not perfect. And this is why, especially in larger enterprises, the main things we see people working on are actually internal tools, because the cost of an error there is much lower than if it's kind of like customer facing. But chat over your unstructured data is something that previously was kind of like not really doable, now is doable. It's pretty easy to get started with. Weirdly enough, like the structured data, where there's probably more analytics before in terms of like, yeah, Excel and SQL queries, that's actually harder. And we're seeing like there's a lot of startups that are trying to solve this. It's actually a harder problem. And so I think like in terms of chat your data, we're definitely seeing like chat over unstructured, just like raw pieces of text. Be one big application. Another one, which I'm very bullish on and I think is a good place to start, is also extraction of information from these documents. And so this maybe isn't something that's done live. Like you might not ask it a question, but it's rather you have some pre-processing step where you extract information and then put them in some type of SQL query where people can analyze it. Those are two of like the larger kind of like use cases that we see people getting started with, and the formulas there are relatively standard, and it's kind of, I think those are two great starting points.
I got two quick follow-ups and then we'll get to you, Kathan. We talk about chat. I actually don't like chat. I like chat for support. Like I like chat when like I need to change a flight with Delta, and the thing that I like about chat, I actually like chat with a real human. Number one, I can say something once, like my address is copy and paste. And if you need my address again throughout this entire session, you can scroll up and we got shared context. I love chat for that one reason. But I don't like chat when I feel like this thing is guessing and I can just do a better job for someone that had a better mental model of what I'm going through. I am literally stuck on vacation. No, I don't want to leave 4 days from now. That is not, you're lacking context in the discussion chat bot. So this LLM thing, is chat like the number one, I guess, facade that people will interact with these models? Because I would think as an enterprise, chat is one thing, but is chat kind of the core essence of what people will interface with these things?
I mean, I think it's still so early, but I think so far the answer has to be yes. Like, I think like chat is the dominant thing that we're seeing by far. I think I think there's a few separate things there. Like you said, chat isn't good when the thing is just kind of like guessing. Like the big problem here is making these things context aware. Like regardless of whether it's chat or just a question, that's a big kind of like unsolved thing. So assuming you have something that's like reasonably good at that, I think the reason chat is a pretty good interface is also kind of like exactly what you said. You can ask follow-up questions. You have this chat history and you have that as context, as opposed to just if you're asking like a single question and then if you want to like edit something, you kind of need to be able to reference that thing before. And so that chat history provides kind of like a good buffer there. I'll also say that I think like, again, it's just like so early. I'm very bullish. Like a lot of the things that you might ask a thing to do, basically, again, there's so many applications. I'm bullish on like long running things. I think a good example of this is like, you know, when you're asking questions, maybe you don't actually want to be chatting with documents, you want to be like writing a report. And so maybe we'll see applications kind of like transition over to some interface where they're writing a report based on a prompt. But there's a lot more moving pieces there. I don't think we're at that level of reliability yet. So chat is also kind of like a playground almost and provides that kind of UX. I'm also not a UX or a UI expert, so there's lots of other people who have more informed opinions.
I kind of feel like chat is the easiest thing we can perform right now, right? Because a lot of the things that listen to natural language, depending on your accent, the way you pronounce things, it can change the whole query. But it sounds like we're going from a world where you have this rigid structured thing called SQL, and running that on structured data, you can get some amazing high quality results because you have to do so much work when you gather the data, structure the tables, all these things, to a world where we say, hey, maybe you're dealing with unstructured data. How would you query it? I don't think we want to write SQL queries for that. So using natural language via chat, meaning I can spell check, I can get my grammar correct and then post it. And then I have way more time to kind of analyze the text versus trying to decode the sound to make sure that the query is as accurate as possible. Is that maybe a fair way to think about the reason why text-based chatbots are so prevalent right now during this phase of LLMs?
Yeah, I think it's I think that's probably pretty fair. Chat's very accessible to a lot of folks, and yeah, and that's probably a good.
All right, we'll go to Kathan and then we'll go to Steph.
Yeah, so I think I just wanted to add a little bit to both of your parts. Like Kelsey, you asked a very, very important question, which almost got hidden over there, which is like decisions. Like people make decisions today. I would not rely at the moment, and maybe this is a very big statement and people are going to come and probably kill me for it. I wouldn't rely on LLMs to make decisions. What I would rely on LLMs is to help me in making decisions. That's a slight difference, but it's a very, very critical and important difference, right? When you want decisions, you want precision. And by the nature of it, when I say something to you that I went to the hospital yesterday, I have other random context in my brain that I did not even communicate to you, right? Because language by nature is imprecise. And I've seen a lot of applications, and again, another one that probably pitchforks will come out is that people are saying, let's use natural language to query structured data, right? To write SQL. I think it is not right. And the reason why this is like, when you say certain things in English, two people are finding it hard to communicate with each other. How do you communicate with a database that has rules, right? But your rules in your natural language were not precisely given. So you will lose that in the context. That's why we created SQL. The reason why SQL exists, it gives you this a syntactical validator that allows you to precisely follow the rules. And you cannot disobey, right? You cannot just randomly query something. You have to say the primary key or the where and the what and blah, blah, blah. So I think it is really important to understand these two things. Like one is language is imprecise. Hence, I think every application which is unstructured data where imprecision is okay as a response, LLMs are fantastic at it. But that also leads to a point that you shouldn't use it to make decisions. At the moment, maybe at some point we will get there by combining multiple knowledges as well as text and about chains, etc.
And I know you come from the ML ops end, and I remember I was doing an interview around very similar topic around people in the observability space. And I think you talked about infrastructure. If you are going to try to have this thing help you make decisions or cross fingers, make decisions for end users, you want that audit trail.
Yes.
Because you need to be able to reproduce that decision. What was the model? What was the data? What was the situation when you made that decision? So that way humans can go back and say, yo, that's a bad decision that we're making. And we either need to go fix the model or ask ourselves, are we even on the right track with this? And I think this is where the infrastructure part becomes a huge piece of it. I think you even told me once back in the day that it's just not the model. The code alone isn't the model. The infrastructure, the data, and the model all together equal the output and how you need to version these things together.
I'll give you an example on that. We work with a company called Apcelera, and they were the people who found antibodies for the COVID vaccine. So the process of vaccine discovery works where you go and actually a company like Moderna will say, like, I want to just build a vaccine. Let me go first find what antibody should I target or whatever, right? Like, I think this is for the antigen vaccine. So don't quote me if I'm wrong here, but they go to a company like Apcelera and they go through a huge research process to find these antibodies. And these are like including blood cells and, wet labs and electron microscopes. And finally, there are hundreds of thousands of permutations that they go through and finally decide on one and say, like, let's target this one. Right? And then comes the clinical trial process, which you go through. And after that, we had to fast track all of this for COVID. So we went through and we delivered a vaccine. Let's say 5 years later, you find a problem that this vaccine was impacting you, and it had converse effect. FDA will come knocking to Moderna and to the company to say, what were the examples you did? And you have to have a trace of everything. And they are ML driven. In this case, I call this ML, right? It could be called AI, the higher field of ML. This is true in any kind of a place where it's a human making a decision. We work with autonomous companies like Woven by Toyota and so on, right? They do the same thing. Whenever there's a left turn or a right turn to be made, why did you make that decision? What was the set of inputs in my simulation? What did I see? And how was the observation done? And how was you accepted? Like, we have to have a trace because this is not a human making a decision. This is a machine making a decision. The number of times or the precision requirement increases, probably artificially, but it does increase, right? So, and every time it makes an imprecise decision, trust reduces, which is a very, very big factor, in my opinion. But I'll let Steph answer.
Ketan, you're giving wonderful answers. Just give them a little louder because no one wants to miss them. And we're going to go over to Steph. I think you had your hand up next, and then and Mish will go next.
Yeah. I really agree with everything Ketan said. I'm going to go ahead and take a slightly stronger stance and maybe say the opposite of what Harrison was saying and say I think that chat is possibly the kind of like least useful application of LLMs and the last one that is going to see wide adoption. I think like LLMs have been in production in kind of like enterprise scenarios for a long time. And I think ChatGPT really was it was only really revolutionary in like two ways. Like one is the reinforcement learning through human feedback kind of mechanism, I think is really powerful. And we're like ChatGPT is like a testament to that, but it really captured people's imagination by showing them what these large language models could do. Like it's a very interpersonal thing that you can like chat with this thing. It'll treat you, it'll like answer your questions for you. But in fact, like the underlying models have existed and been in production enterprise for a long time for a lot of tasks. And I think like like you were saying, I think kind of Ketan was talking about like there's like real consequences, right, to exposing these like chat models to users, and we really don't have the ability to control them that well, especially in this sort of like unregulated text output sort of environment. So it's really kind of like dangerous. Like imagine, so like one example, kind of getting back to your original point of like experts and like things that experts do that we can train language models to do. So one example application of large language models is like toss violation for merchants at Stripe. So this is a problem that like existed before language models were involved, but you basically want to say like, merchants are only allowed to sell certain things according to the terms of service of Stripe. And we want to like look at a merchant and decide whether we think that they're violating the terms of service, and then potentially like discontinue the relationship with them. And large language models can do like really interesting things with that, right? They can not only say like pull in text and use the text. Like before that, we were just using like a bunch of random signals, like potentially like just like charges or something like that. But being able to really pull in the text is really valuable because, if they're selling something that's against the terms of service, they're probably going to say what they're selling at some point. And so that understanding the text is really valuable. But with large language models, you can go further and say like, hey, what like, can you point to me on the website and tell me like what that reason was? And that's suddenly like a really powerful thing to give to like an expert, and really reduce the amount of time that they need to spend doing this, and say like, okay, we think, not only do we think here's a merchant that we think is violating terms of service, we've done a bunch of the legwork for you to make that decision, and then we like have all those records available for you to like store in case there's like a lawsuit about this later, right? Versus like, I don't know, like directly sort of interacting with the user without a person involved would be, I think, so much harder of a lift, right? You need to be both very confident, and like you can't really control necessarily what the bot's going to say to them. So I think there's actually a huge amount of use cases already that people are using large language models for. And I think that what we'll see is that like a lot of the use cases longer term are going to be these like more specific structured problems. And maybe there will be some interesting generative ones as well, but I would say those are going to be kind of the minority of cases.
And Mish.
No, I think all good points, right? Like the only thing, like in general, in terms of models making decisions, they've been doing for quite a while now, right? They are not necessarily LLMs, right, but LPMs and others, right? From the point of, when we are applying to a company, your applications going to universities, submitting a loan applications, models are making that decisions, right? And so far, a large number of enterprises have developed strong enough, governance capabilities to be able to capture the lineage and the metadata, so that, yes, in case of a compliance or audit, right, you are able to go back and trace. I think LLMs as such, the fact that it's a language model catered towards language processing, more geared towards, augmenting and giving you knowledge to be able to make those decisions, right? And that's where the benefit shines, right? It's able to summarize tons and tons of data, right, and give you a very precise analysis of, what that data means, and then you can based on that, can make decisions, right? Now, the other point, vis-a-vis the interface, I think it's in general, like, the way you talk to a machine, whether you are going to use a voice or you are going to send some form of text, right? I mean, these are the only two modes of interaction which exist. So in general, like, I mean, LLMs are becoming that voice of machines, right? So either you are going to send some text or you have voice enabled interfaces. And in a lot of cases, like, there are use cases emerging where people are interacting and not knowing that they are actually talking to a machine behind the scenes, right? So they're able to reason, they are able to contextualize, they're able to pull in more information. So I think the early generation chatbots, they were definitely very clunky. You could definitely tell, right at the outset that, hey, you're talking to a chatbot, right? There is not a human behind that. More and more what we are seeing in the next generation of chatbots which are coming, right? It takes a while, even if you're able to determine that you're actually, talking to a chatbot, right? So they're becoming better and better. So I think chat as an interface, and then, voice as an interface to talk to these different software systems is going to proliferate overall. And some of the use cases, like even within LinkedIn, right, which we are seeing, personalization is a great use case which LLMs have enabled, right? So for example, recruiters need to send emails to different candidates. What was happening was, you have a lot of these generic emails being sent out. Right now, what LLMs are able to do, look at, the company context, the recruiter context, the applicant context, their profile data, their activity, and they're able to create very, targeted, personalized emails, right, which you can actually send out. other set of use cases which we have enabled using LLMs, right, within the context of LinkedIn, for example, collaborative articles, right? So a lot of professional network which exists on LinkedIn, right, has knowledge about certain things. So being able to generate these collaborative articles around a certain topic and then seek inputs from different humans to augment that machine generated article, right? We are seeing a huge uptick on those, right? So I think in these kind of cases, LLMs are proving, very, very beneficial, where the context is more around qualitative data generation, summarization, analysis, right? And then you have the other set of models, right, which are right now dominant in the decision-making world. Yeah.
What's interesting, I think for a lot of people, they're first interacting with the machine, maybe be through touch, like you touch something and it does something, like, a very simple machine, like a thermometer, right? What's the temperature of me? You put it in your mouth and it does something. Very simple machine, does one particular thing well, but it's a really nice feedback loop with human interaction and a machine. And it feels to me like the machines and the software we interact with is so complex that now you can't just use a dial or knob or figure out all the commands or the API in order to discover all of its capabilities. Now we want to go into the most powerful interface that humans tend to know. Like if I walk up to a person, I have my entire language and vocabulary at my disposal to query this person's capabilities, ask them to do something. And if that person has the skill, they can take my query and turn it into some actionable outcome. And I think now people are saying, is it time now that this thing we interact with so much in our lives, almost as much for some people listening, you probably interact with a computer more than you interact with humans. And now I think you want to upgrade the interface and the protocol you use to issue and receive answers. And I think that might be why I think a lot of the hype is there. And I think what ChatGPT did for everyone, it gave people the ability to experience the checkpoint of where we are. Is it great? Is it something that I think we'll do forever? Probably not. But I do think it's that checkpoint that the whole world, millions of people simultaneously could experience and say, oh, this is where we are. Because before I used to use those, speech to text to try to write docs. Like it wasn't good. I just went back to my keyboard. Now this thing is like, yo, not only can we do speech to text, we can generate what you're probably going to write anyway. Given that, I'm going to pivot to the next part of the conversation, which is one thing that I think I heard come up a little bit is around this stuff is powered by data. Someone asked me a question what I thought about LLMs, and I said, listen, LLMs highlight to me how valuable humans are. Instead of sitting in front of ChatGPT all day, I want to be the training set. I want to go live a world that generates the new model, the data that I do from my activities in the real world, feed into some model for someone that wants to sit behind a computer, because I don't. Now, the thing that makes most of these enterprises interesting to me is their unique data set. I kind of feel like these models will race to open source. The model itself will be generically available, but I don't think the data will. Anyone want to jump in and what impact will a unique data set, will that give an enterprise an advantage? Do you all see data sets also becoming a great commodity as well? Because that seems to be a huge part of this whole movement right now.
I think in general, there are definitely the advantages of, having your own data set comes in the context of fine tuning, right? So one of the things which we are typically seeing, right? I mean, models, general purpose models are very good at, generalizing and looking at, giving at more generic answers. But when you are talking within the context of an enterprise, you need to have that proprietary data set on which it is fine tuned on. Otherwise, the answers are probably, full of hallucination. Then you are also, getting a lot of the biases and other things on which the genetic data set on which the model was trained on. So a lot of fine tuning which is happening within enterprises is make it domain ready for my enterprise, right? So, okay, we have, for example, just from the context of within LinkedIn, these are different profiles of members, right? So let's, train and fine tune on some of that data. The second thing is, checking a lot for hallucination and trust and bias, because, these are going to become the voice of the enterprises. The way these LLMs are being positioned are, these are your chief of staff or co-pilots, which are essentially, speaking on your behalf, speaking on your for your brand. And the more the distinction vanishes between, whether a human is speaking or a chatbot is speaking, the higher the guardrails which need to be developed so that, you are very, very strongly checking for all these different things, hallucination and biases. So I think definitely it's a need of the hour, right? You cannot, for most of the enterprise settings, you cannot take a proprietary general purpose language model which exists and then, create a brand offering or a product offering within an enterprise out of it. You will need to create your own data sets, unique data sets on which you need to fine tune, refine, make sure you are getting rid of all the other toxicity, hallucination, and other things before you can actually, launch a product. And this is a process I see any brand worth, which wants to go and launch their own LLMs and chatbots, etc. They will need to follow. So more than an advantage, I think this is a necessity at this point, that you've got to have techniques and platforms and proprietary data sets to fine tune these models on. Yeah.
Before I swing it over to Nyla, I think you had your hand up there. I have a follow-up question, because when we say data sets, I think some enterprises may be thinking like just random data dumps, just random data sprinkled throughout the enterprise, put it in the data lake. We got our data now. It almost sounds like you're saying is that expertise that we talked about earlier, like the people who kind of know, it's almost like they need to serialize a lot of that context, right? Those various data points, because some people are just not capturing this unique data, right? They're just like, well, we don't get it from our sales register, and we just know it's there. We make decisions by intuition, or we don't even save that data. We just look at it, and every 10 days we throw it away. And it sounds like a lot of this data that feeds into that expertise needs to be serialized and treated as almost this versioned thing that is almost as critical as the model that you're trying to generate. So is that also one of these steps that you need to go from? I think I remember that hierarchy is like data, information, knowledge, and then wisdom. And a lot of people have a bunch of data, the last 15, 20 years of big data, but then that data needs to be curated. I think, using your words, that curation turns it into like information, and ideally combined with ML, it becomes knowledge. And then how it's being used, I think that's where the wisdom comes in. So hopefully that's a good way for people to think about going from just raw buckets of data, hoping for the best, to really thinking about moving up that knowledge pyramid into something that's actually usable. Nylan, I think you dropped early. If you could introduce yourself and then maybe jump in on the topic.
Yeah. So I think I was actually online, but I think maybe for some reason it wasn't visible to you guys. So just quickly, giving my introduction. So my name is Nalan, and I'm working at NVIDIA as a senior software engineer. And we have been actually building, some of these conversational AI-based intelligent kiosks, which actually kinds of, amalgamates the conversational AI, the natural language understanding, recommendations, vision AI, all of them clubbed into a single thing that, you come in front of the kiosk, you have an interaction with it, and it understands you, and it understands even your emotion using the vision, and it can also, do some recommendations or certain things like that. So yeah, I mean, that's kind of, the quick background that I have. And just kind of jumping back to, some of the points that Animesh was making about hallucination, right? And how they're actually augmenting it together with the profile of the user. So there are actually two things there, right? First one is what Animesh has already mentioned, that you have a set of these documents and you basically do some sort of a retrieval in order to make sure that, you have the versioning correct. For example, Kelsey, you were mentioning that if let's say you have version 1 of the document and then you have a version 2, and you want to make sure that now, given that you have an AI which can do a question answering on top of it, you want version 2 to be used instead of version 1. So that is where, the whole information retrieval based LLM models comes into picture. And that is something that, I mean, ChatGPT or some of these usual LLM models only don't support that. But given that, what Animesh was mentioning about these LinkedIn documents, then you can basically club in those, contents that you actually retrieved from the query first, and then you basically use that together with the chat GPT or an LLM. And that kind of gives you an edge that, every time you have a new version of the document that comes in, you really don't have to worry about fine-tuning the LLM. You can just keep using the same LLM, but basically change the information retrieval on the initial stage of the pipeline so that you get the up-to-date information from the top.
You know, it
So
sounds like, if I were thinking about someone being a lawyer and they're about to give an answer that can determine my fate, I would like them to check their notes. Actually look
Yeah.
at the legal precedent before. So you have a good model, you've been a lawyer for 20 years, but it would be nice if you actually had the current set of laws on hand before you give your recommendation. Could you just double check the actual known facts? Could you look at the elements of my particular case? Like, oh, I defend people who run stop signs all the time. You'll be fine. I'm like, hey, whoa. Make sure you understand what state I was in, what city I was in, what the actual laws were before you give that recommendation. So I think that additional context, if I had to try to put it in an analogy form, but I do have one question for you now. I'm pretty sure any enterprise that's watching this right now, you being from NVIDIA, there's only one question. Where the GPUs at? And like, why they cost so much? Where are they? And why is the GPU so important to this whole process, right? A lot of people are familiar with Intel Inside. Most people became aware of NVIDIA probably through its stock price or a video game they try to play. And then here comes this world of LLMs and AI ML in general. And it seems like NVIDIA is at the center of that. It can't just be GPUs. So maybe give people a little bit of peek into how the hardware plays into
Yeah.
all of this.
So it's basically an amalgamation of a lot of different things that come with the GPU itself. I mean, talking in a very layman term, what a GPU ends up doing is that you have a, let's say, a model that is running. What you try to do is that instead of you just having maybe a single processor which is doing the whole analysis of the data, you now have basically multiple threads. So instead of a single CPU, you can think of it as like having 10,000 CPUs, all of them working in parallel and doing the same thing at the very same time. So what ends up happening is that you are actually reducing the latency. Instead of it taking 10,000 seconds, now you're just taking just a single second to do the same thing. And given that all of these large language models are actually quite compute heavy, so you can't really have an Intel CPU and ask it to do the same thing as what maybe a GPU can do. So it's all about parallelizing, the compute efforts of ingesting the data and coming up with the right sort of the model. And also on top of the GPU, now we have this whole ecosystem where you would also need the libraries and the software tools on top of these individual GPUs to be essentially to be able to make it easy for the people to come up and use it. For example, any person coming outside of the background of GPUs, they don't have to worry about coding the actual GPU code, because that needs a lot of expertise. So basically, you create all of these abstractions, basically create these tools, which makes it easy for an end user to be able to use these GPUs and essentially come up with a set of requirements that they have and be able to do that efficiently.
All right, well, look, we got 7 minutes left. I think, Keithan, you wanted to jump in on this one. So you'll do that, and then I'll go pick our next topic.
Yeah, I'll do a quick addition over here. So I think this has been, NVIDIA's presence in this has been in progress since 2006 and 5. Like at that time, there was a GPU programming trend, like general purpose GPU programming. In fact, 2007, I wrote papers on GPU. And I was like working in a lab that was trying to make sense of what to do with this hardware. Because if you think about the hardware, it's a mini supercomputer, which is not really very smart. So in a general processing unit, you can do one operation well, it can do branch predictions and so on. This thing has thousands of computers or processors in it, but they're very dumb. They're all controlled by this one simplified processor. So they can only do one thing really well. And actually the one thing turns out to be really, really important for gaming, for AI, for ML, for crypto, for a bunch of things, and that is matrix multiplication, because that's like the core of all of this. And because you can have integrals and calculus. And that's where this came on. I think it has been tuned to do this really, really well. by a lot of grad students to NVIDIA company to all kinds of people. And this is just an amalgamation. And like when I was working on 2007 on GPU, I would cry saying that this thing just goes offline all the time. I didn't know in 2011 that somebody will build a vision model that beats every model that has happened till now. So it's been happening for 15 years, just us not knowing it.
All right, so with these last 5 minutes, I think if you're an enterprise user, there's so much to take away, and I'll summarize at the end. But people are pretty curious. Some people, they need to have an answer for their next board meeting. Like the board needs to hear something. What are you doing about LLMs? Even if they don't know what it means, they got to have something. And so I'm curious to know, have you seen any enterprises, right? If maybe you can't mention the name of said enterprise, but it'd be good to understand what they do and how, specifically for this topic of discussion today, LLMs has made a material difference, and how is that material difference either experienced by their customers or their internal teams that are making decisions? If anyone has any real world example, like this is the number one question that I get from a lot of enterprises when any new technologies is introduced. Who is using it for something real? And that helps people gauge the sense of maturity, or is this just going to be a fad and fade out eventually? Anyone want to jump in?
I think I talked essentially, I cannot talk about others, right? But I gave a couple of examples, right, within the context how we are leveraging it for LinkedIn, and definitely, we are seeing a great overall, engagement from the users on some of these capabilities. And you may not, even realize while you're using it, but we have seen, a whole lot of email acceptances when recruiters are sending these more personalized emails, which is then, behind the scenes powered by LLMs generating these emails, which are contextually targeted to the particular applicant, right, based on that. So that's a great uptick we are seeing. Definitely a lot of the premium members who essentially are generating headlines and profile summaries for different LinkedIn profiles, they are actually, we are seeing a lot of usage behind that in terms of, being able to create more catching worthwhile profiles, which are, being looked at more. So I think in general, there is material difference which is happening. I talked about the collaborative article space, right, where we are actually able to generate a lot of these collaborative articles based on the content which is being posted on LinkedIn, and then select different experts, again, being powered by LLMs, to actually then come and give their more human view on those collaborative articles. So a lot of these great use cases which are being powered right there on LinkedIn. So from our perspective, I think it's real. It's getting great user engagement, and there are benefits which are being realized.
Name it.
Yeah, and adding just one more point to it, so we have been talking about LLMs for now only, but I mean, in the near future, and even what is happening right now is that you are having basically multimodal systems. So you're not just talking about chat, but you're talking about vision together with language. You're talking about speech together with language. For example, Meta recently, came up with a model where you can just type in and say, okay, give me a sound of, a train which is whistling a lot, but it just passed me by, and it gives you basically a speech out of it. So in terms of the application, it is not just limited to just the language part of things, but as things grow, you would see that there'll be like tons and tons of different applications. We have things where people are even creating a complete episode out of just nothing. You just type in a prompt and it gives you a storyline, it gives you dialogues, it gives you speech input, it gives you vision. So you can basically create anything out of it in the near future. So yeah, applications are pretty broad.
We'll probably have to do a part 2 of this at some point. We're almost at the end of the whole hour. And I'm going to try to summarize, because I definitely think I've learned a little bit, and also gave me a lot to reason about and think about. When we think about humans, we are very, very advanced, complex machines. If you appreciate machine learning, you should really appreciate human learning and context and experience. And that context and experience that we have, that we walk around with, well, that's our little personal models. And sometimes we choose to share those models with other people. It could be experience in the movies that we make. We're really elaborate. But one thing that we do is we use language to communicate, verbal, physical, every interaction we typically have starts with some form of communication. And that's how we do it in a very advanced society. And now what we want to do is kind of raise computers as advanced as we think they are. We've been interacting with them in mostly primitive ways, typing on the keyboard, having to read all the documentation before you can do anything useful with most of these computing systems that we interact with today. I think we're moving to a world where now we're starting to understand the human interfaces we use, vision, speech, all of these things we want to now see being applied to our machines. But also, we're now asking these machines to make even more complex decisions than before, not just selling stuff at a known price, but making a decision on where we should go on vacation. And decisions come with responsibility. And so I think we heard some really good advice around, you just don't want to go get a generic language model and start giving advice to your customer base. What's the point? That's a race to zero. The reason why you're in business is because of the model you actually have of the world. And your data should reflect that. That unique data set is what makes your company a lot more interesting than another company. And it's only when you combine this new technology, it's still technology. Large language models are just another example of technology. But when you combine it with this know-how, that's when you get something special. So if you're an enterprise thinking about what your approach has to be, it's not a copy and paste, just go and pay OpenAI a bunch of credits to access their API. You got to go deeper than that. You have to spend as much time curating the machine as you can curate the experts that serve your customers. So with that, I hope you enjoyed this panel. I want to thank all the speakers for hanging out with us today. So much interesting context, and you've given people like me a new way to think about this stuff end to end. We'll catch y'all next time.
Thank you.